All right, good morning, everyone. We have another video ahead of us. Now we're in our unit talking about the periodic table. So we want to take a little bit of time and see about the history and origins of it, and then move into now some of the properties and things we're going to cover. Now, this will only be the first video of the ones we're going to do. So don't worry if we don't get it all in. Also, make sure you take your time and rewind if necessary so you can make sure you understand what's going on. So let's get started with our good buddy, Dmitry Mendeleev. Now, Mendeleev is the one who created the first accepted version of the periodic table. As you see this picture coming up on the side. Now, how did he arrange it? He was the one who arranged the periodic table according to atomic mass. Now, along with lining it up, in terms of atomic mass, he also found that they had some other properties that were also very similar. So we want to go ahead and take that information and sort of see what those other things were. Now, looking at this is a basic draft of what his periodic table looked like. If you notice here on the side, we have these groups right here that have these question marks next to them. Why did he write these question marks in the middle of everything? Well, his understanding at the time was there are some elements that are still out there, but we just hadn't found them yet. Now remember, this is 1869, so this is very, very early. This is a lot of time has passed, and we continue to find more and more evidence of other and new elements along the way. But his understanding was, if I can figure out that the properties are similar, eventually I'll be able to find the element that fits into that space and be able to correctly identify it. Now, periodic table itself is organized in a particular way that gives a lot of information. This is going to be your greatest cheat sheet in the world. If once you understand how it's organized and what everything looks like and where it is, this will be your best tool, and you'll be glad that I allow you many times to use these on tests. Now, you'll be able to tell so many different properties and so many different things about it, looking at all 118 elements that we're working on here. Now, these are some common elements and symbols, and I included these in the list because these are some of the ones that a lot of people tend to get wrong. Things like, well, nitrogen is not too bad, but sodium, most people usually look for S or SO, but sodium is Na. And a lot of these are based off of actually Latin names. So that's a little bit different than what you would have normally expected. But take a few moments, get acquainted with your periodic table. Look at the one that I gave you. Look at all the information that's there to make sure you start to realize where things are located. That'll make your job a lot easier when it comes to the next part of your work. Now, the elements themselves can be divided into three main categories. The big blue section being our metals, the green section, light green, being our nonmetals, and in between we have our purple, which are our metalloids, which are going to exhibit properties of both metals and nonmetals. Metals themselves are going to be good conductors, shiny, ductile, which means they can be stretched in the wires, malleable, which means they can be pounded into sheets, and when they react with water and many other acids, they're going to have corrosion result from it. Now, corrosion is sort of like breaking down, not necessarily rusting, but when the metal itself begins to weaken and break down. What about our nonmetals? They're going to be on the opposite end of the spectrum. They're actually going to be poor conductors. They're going to be, they're not ductile or malleable. They're dull many times. They break very easily, and a lot of them are actually going to be gases. This is going to be how we differentiate between our different types of elements. And we're going to use this information once we get into our bonding unit to help make sense of a few other things. Now, our metalloids. Our metalloids are sort of the halfway point between. It's the, conductivity of the metals with sometimes being a little bit brittle like the nonmetals, or shininess of metal, or they could also be dull. So you have to pay attention to which specific metalloid that you're dealing with. Silicon here given to you is the one that we usually are most familiar with, and it's mainly because when we look at our computers and iPads and all these different things, these are the ones that actually help to power and to handle the processing for these materials. Now, how else is this periodic table actually organized? Well, one way we look at it is they're grouped into families. These families are what we're looking at here. Now, in the same way as you and your family may look very similar, you may look like your mother, or people may say you look like your dad, the same way happens with elements. They may not look all the same, or sorry, many of them within a period, within a group will look very similar, but they will also have very similar characteristics. And these are going to be our vertical columns, are going to be our families or our groups. But at the same time, we also have to worry about what happens as we go left to right. And these are going to be our periods. So the periodic table, these are the periods where we're looking at these patterns, these properties being repeated. Now, you notice that within our periods, they don't necessarily have similar properties. We always start off in the similar way when it comes to our periods, and we'll come to that in just a second. Now, once we look at some of these families or some of these groups, we're going to start to notice how similar they are. Looking at a couple of different things, they may have similar but not identical properties, like the example given here with our group 1 metals, lithium, sodium, potassium. These are all going to be soft, white, shiny metals. So with the activities that we do, you may want to pay attention and watch out for, okay, what type of formulas are they forming, or what are the descriptions of those things. The other thing is, and this is going to be very important as we get to bonding, they're also going to have the same number of valence electrons. So keep that in mind. Now the periods, we're just going to be able to notice a single pattern. And what is that? They're going to change a lot, but they're usually going to start with an extremely active solid and always end with an inactive gas, starting with our alkali metals and moving all the way over to our noble gases. Now, let's talk about the alkali metals. This is where I like to sort of get into it. When we look at some of these properties. Now, it's going to be the first column of the periodic table. Notice that it does not include hydrogen. Why not? Hydrogen itself actually is a nonmetal, but it's grouped with the alkali metals because it has similar properties and how it reacts. Now, all of these are going to have a single electron in their valence shell. So 1 valence electron. Again, we talk about they're shiny, they're going to be soft, and easy to cut with a knife. Now, in terms of their reactivity, this is where the fun begins, because they're going to be the most reactive metals, reacting with air, and especially if you put them in water, you'll see a nice little explosion that happens. Go on YouTube, check it out. I think you'll enjoy it. Now, we will never usually find these in nature because they are so reactive. That's one of the keys that goes in with it. And unfortunately, we're not allowed to have it here in the school for safety reasons. But that's why I want you to go ahead and check out the video and just get an idea of what it actually looks like. Now, alkaline earth metals. These are going to be our second group over from the left. These are going to be usually found uncombined in nature. They're not as reactive as the alkali metals, but they are fairly reactive still. They're going to have 2 valence electrons. So hopefully you're starting to notice that little bit of a pattern. First group had 1 valence electron, second group had 2 valence electrons, which we're going to talk about a little bit later. Now, transition metals, this big group here in the middle of the screen. As we look at this, we're going to notice that it's going to have a very, very large amount. Before we were just looking at single columns, now we have this big, big group. Because of that, it's because they actually have a lot of different properties and they don't all fall within the same pattern. When we think transition, the word transition, we usually think change. So these are the elements, these are the metals that their properties vary a lot, and the number of electrons, valence electrons that they use are actually going to change. So that's why we have our transition metals. Now, a lot of these metals are actually going to be used for our artists out there to color different paints or to form these different compounds, to do all these amazing, amazing things. They all have properties that are similar to other metals, but they don't all fit within one specific family. So you're going to see actually variation and similarities between a wide range, but there's such a large group that we couldn't necessarily fit them all into one long column. Now, when these metals actually combine with oxygen, we're going to say they form oxides, metal oxides. But we'll talk about that in a little bit. Now, we skipped over just a little bit, and now we notice we're all the way over here looking at the halogen group, the halogen family. This group right here. Now, we said this one had 1, this group has 2. We skip over a little bit, and we're looking at the halogens, which now has 7 valence electrons. Some of the ones that we're looking at here, and you can use your periodic table that I gave you in class to sort of picture this, it's going to be bromine, chlorine, fluorine, all those. Now, because of the fact that they have 7 valence electrons, this is going to cause them to be the most active nonmetals. So, alkali metals, the most active metals, the halogens, most active nonmetals. They only need 1 electron in order to fill the outermost energy level and fulfill the octet rule. We'll talk about that later. But because of that, they're always going to be going, always going, always going to want to be able to finish the race, almost there. Now, the last group we're going to talk about today is actually going to be our noble gases. Now, we've heard of the noble gases usually before we get to this point, and that's because they are the gases and the elements on the periodic table that don't like to react with anything. All right, now, most of them are going to be colorless, and they don't readily react with anything, but there are some, xenon in particular, that actually will react, and so you want to pay attention to that. But the big key point here is they're called inert. Why? Because they don't react, or they don't combine with other elements. They don't play well with others. That's why we say the nobles. If you think back to history, that's how we usually talk about them. So far we've covered all of the groups that you need to pay attention to, except the last one, which are the rare earth metals. And these are that group that's at the bottom of the periodic table. Now, usually these actually go in, if I was to draw an arrow, they technically go in there, but that would list in the periodic table, so we pull them down so that their properties are sort of listed together. Now, these are going to be mainly radioactive. A lot of these are actually going to be man-made and found in the last century. So you want to pay very, very close attention to these, because we're going to use them for little things here and there. But this concludes the video at this point. Rewind, take your time, go back and get all of the information that you're going to need. We have some activities lined up when you come into class. Can't wait to see you. Have a great evening.